we have a question. We have to find 11th nearest number to 4-digit largest number, which will give a remainder of 7 by 15. Solving these questions, we just use the basic concept of maths. We have a divisor 15. We want remainder 7. So can we write the number is in the form of 15 and plus 7? With the condition apply, n should be integer. Means we have to just find the integral value which is in the form of 15 and plus 7, and we are looking for 4-digit largest number, or we can say we are looking for the nearest number which is 4-digit largest number. So I am just equating our required number to 4-digit largest number. If n is integer, we will get the value. If not, then not. By solving this, we can find that n is 4-digit largest number minus 7 upon 15. Here we find n is equal to 666.13. Can we say n is 666.13, which is not an integer? So 9999 is not in the form of 15 n plus 7. But our question is not okay, this is in the form of 15 n plus 7 or not. Our question is we have to find the 11th digit nearest number, 11th nearest number, not a digit, 11th nearest number. So we find the integer which are near to this. Can we say our first integer which is near to this is 666, and the second integer which is nearest to this is the 667. Can we say I am saying this is the first integer nearest is because here the gap is 0.13 only from this number. Here the gap is 0.87. So if we put and 666.13 is the value for the 9999. For this 666, we get the first nearest number to 9969, or the first nearest integer from this n. We are comparing everything to n because for this n we are getting 9999. This is my second nearest number. If I down this value 665, here the gap, if you count, is the 1.13 from the n, and 1.n is nothing but 9999n. If we increase the value 668, here the gap is 1.87. Can we say if we go increasing the values from the 667, we are getting farther the value from this. So this is my first, this is my second, this is my third nearest, this is my fourth nearest. Can you say by seeing the series we can say okay, the fifth nearest would be this side, sixth nearest would be this side, seventh nearest would be this side, eighth nearest would be this side. Means we are looking for the 11th, means odd nearest. The odd nearest would be the decreasing value of n, and the even nearest would be the increasing value of n. So we have reached 1, 3, 5, 7, fifth is 664, seventh is 663. If you are going for the ninth, because we are looking for the odd every time, is the 662, and then after ninth we are getting the 11th nearest number. The value of n is nothing but 661. So what we are going to do is finding the value of corresponding n, and we know our number is in the form of 5n, 15n plus 7. So our required number is equal to 15 into 661. I am taking 661 from here, 661 plus 7. So our final answer is, by solving 15 into 661 plus 7 is 9922. So this is our required number. This number is 11th nearest number to the 9999. We find the n for the 9999. We find the integer which is 11th farthest from this n, and we get the number is 9922. And among the options 9922 is nowhere, so our answer is none of these, and this is the number, and in a none of these our number is 9922. So I hope this method is clear to you. Just find a n for your number, and from n get the integer which is nearest or farthest, and 99% of the time you will get all odds are in the 1 times and the all evens are in the 1 sign, and the 1% is when we get 0.5. If this one is a 0.5, you have to note that the first, both two are the first, both two are the second, and so on.